let's get started.
Okay, hello everyone.
Are you guys with us? Mr. Derek, Mr. Olu?
Yes, sir.
Okay, please let's pay attention. Okay. This is the basic, and we're gonna run this once, and we're gonna be able to get it straight from here. Go ahead, Jose.
So we'll be doing some revisions today. And if there are any questions along the way, you can let me know. So we'll start from the basics of the operations we can do on Python. So like I said initially, we could do basic maths operations. Like from this first line, we have 7, and this symbol means multiplication. So 7 multiplied by 10, around that we have 70. And this is the division symbol in Python. 10 divided by 5, around that we have 2 or 2.0. Then we have the addition operation. 10 plus 10 will give us 20. Okay. So then we have what we call variables in Python. You can say variable, it's like a placeholder for something. For example, we want to represent, we have 2 numbers we want to add. We can say we want to represent the number by x, and say let x be equals to 3. And we can have another number. We can have another number, say y, and say let that y also be equals to 6. So this x here, we are assigning 3 to it. And this y, we are assigning 6 to it, because we have this equals in front of it. X and y have become variables. Variables simply means that its value can change at any point in time. So it's not a fixed value. So like it's varying. That's what it means. So with this, we can, instead of adding 3 and 6 directly, if you want to do an addition, we can say x plus y, and that will give us another value. Now it's 9. It gives us an output called 9. So we can also do same other operations. We can also carry them out with variables. We can say x divided by y. It will still give us something. Now 0.5. And same multiplication can also happen with variables. 8x times y is 18. So a variable you can name, if a variable can have any name, the rule is that it can either begin, a variable must begin with a word. That's like alphabets A to Z or an underscore. It should never begin with a number or a symbol. That's for Python. For example, you cannot start start a variable name with cannot say, okay, let me see what we can do first. We can call in name our variables, for example. John. This can be a variable. Say John is equals to 7. That's a good variable name. And we can say, because we can say we is a variable, is a good variable name. And we can also say that we can begin a variable name with an underscore. So I can say underscore James is supposed to something. This underscore James is also a good variable name. And that's a valid Python code. But then when we start doing something like this, 1x, it doesn't make any sense. It cannot work. This is a wrong way of naming a variable. Is equals to 3. This will give us an error because it's the wrong way to name our variables. So a variable name must begin with, first of all, it must contain an alphabet A to Z. You can include a number within it, like say x, 1x. Yeah, this is a variable name that can work, but you cannot begin that variable name with a number. That is very wrong in Python. You cannot begin it with a number. You always get an error. That's a rule we should always remember. Okay. But then we can begin it with an underscore. But a variable name must always begin with a letter or an underscore. Thank you. So let's move on to printing. Now, printing is just a way of putting out, representing our output to the screen. So anything we want to, for example, we want to bring out a value. First of all, print is a built-in function in Python. There are several of them. So, but print is commonly used because we use it to present our results to the screen. Not every operation will be automatically outputted when we finish our calculations or running the program. So we use print to display our output. For example, if we say John has 10 balls, and James has 11 balls. So how many balls will both of them have? And say total balls will be equals to John plus James. So to get this result out to the screen, we can just print out total. Notes. And that would be the result to be 21. So we just use the print to print out the results to the screen. Or we can see so we just use the print to print out the results to the screen. So that's the use of print in Python, the print function in Python. There are other built-in functions too, like type. So before we can use type, we need to know what a type is. So a type is just like a representation of when we talk of types, we are talking about how we represent our data in programming. For example, one of the basic data types we have are strings and then numbers. We also have booleans, and then but the basic one for now we need to understand is strings and numbers. And when we talk about strings, what do we mean? Can you remind us what strings are? Yeah.
Strings are queries.
Not exactly.
I think strings are data. A data is called a string when it is represented in a with an inverted comma in an expression. That kind of data is that means that everything in that expression is the same or is in a group. So that symbol of the inverted commas are used to express that they are in a string. I don't know, but that's just my way of understanding it.
Yeah, a string is simply just anything represented within a quotes. For example, when we have something like this. Yeah, when we have something like this within a quote, whether it is single or double. This is a string. Or we can also, in all programming languages, we have single or double quotes can be represented as a string. But Python also has, you can also use the triple quotes. Also, string. So once anything is in between this quotation mark, it is a string in Python. That's one, those are data types. So most of the time we use strings to represent simply words or things like that, or names or things. That's what we use them to represent most of the time. Or to print, or statements to be made. That's how we use them. That's what we use strings for. And we also have another data type, it's numbers that we are very familiar with. It can be an integer, which is one, for example, 1 to 3. So this is an integer. And we have decimals, which we are familiar with. What's in Python, they are called floats. So these are strings and these are numbers. But then they are also grouped as, we have the integer, which are whole numbers, and then the floats, which is decimals, right? So if we have, say we have we say x equals to, say 100, and we want to know what data are we assigned. We assigned x to 100. We assigned 100 to x, and we want to find out what type. Maybe we've forgotten at a point while programming. Want to remind ourselves what type it is. Then type x. That should give us, print it out to the screen. So what do we think the answer will be? So we are told is an integer type. So we have a y equals to, and we want to find out the type. And that's a string type. So this is we use the type to check what type it is. That's a type function to check what type it is. So when I say function, usually what it means is, when we have something like this, we can have a name and then a bracket in front of it. That's the simple definition of a function. For now, let's leave it at that. Later, we'll further explain it while we further explain when we start making our own functions. Usually, a function is a block of code, just a block of code that does specific tasks for us. But for now, this is what let's just say a function is a word with a bracket in front of it that will return a value to us or something. So these are the types that we have, the basic one. Then here to show syntax, to show how the syntax of Python works or how it doesn't work. For example, what is syntax actually?
Syntax. Okay, go ahead.
Yeah, let's just say it's a rule that is supposed to be followed by a programming language. So every language has its rule that we must abide to. That let's just say something that is just we don't need to understand how it works, but these are the rules that we must abide by for it to work or for it to do what we want to do. You don't need to understand the logic behind it. For example, we have here, we're trying to assign a variable. We are trying to assign a value to a variable y. But then we have this thing here. It doesn't make sense to it. So if we run this code, we see that our interpreter is complaining. Yeah, what does this mean? What are we trying to do? So this is an invalid syntax. It doesn't follow the Python rule. Yeah, we have a string here, and we have this thing that it doesn't understand where it is from. So what it's supposed to do, it doesn't know. That's what it's called. Then we have the syntax error. It doesn't follow Python's rule. It doesn't understand it. I hope you understand that. Yeah. So whenever we see syntax error, that's what it means. I think that is the most common error, especially if you're just starting out programming. There are other types of errors which you might encounter, but this is the most common one you see for now. So let's move on. And any questions so far? Hello?
No question.
No question.
All right, let me move on. So when we're working with strings, there are some things we call methods. So there are some built-in methods that can be helpful to us. For example, say so we have this variable name. Say we want to, everything now is in lowercase. And we want to make it turn this whole thing, into, say, a title, make the first letter an uppercase. There's something we call this, methods that can apply to any string. And we can see rings name dots. Let me put a dot like this in front of a variable. It's called and we want to call a method on it. Sorry, it's wrong. So what happens? Turns it into a title case. So the first and second word will become uppercase. That's what title does to it. So if you want to make everything an uppercase, it's already in lowercase. So let me use something else. You can do this with any string. So it has turned this to lowercase. You might not necessarily assign it to a variable before doing this. For example, we can say I want to turn everything into an uppercase. This will still give us results. And that's it. So let's talk about another data type. And it's a little more common also, but not as commonly used as strings and numbers. So we have lists, what we call lists. Okay. Do you have any question?
No.
Okay. Yeah, so let's move on to lists. Hmm. Can remind us what a list is, or what we understand by list. Mr. Derek.
Yeah. So what do you understand by the string?
A list, a list, a list.
Just present what we have in the table. Or list
No.
what we have in the table.
No. Mr. Olu? No.
A list, I think, is like an instruction. It's a language. It's an order of language or instruction that we give in a message. So I don't know if that is.
No. No.
Is an accounted order of a language. So, but I don't know. I don't know how to explain.
No, a list is just a, let's see, a list is also a data type, but this we use to represent a collection. We use it to represent a collection. Like, for example, you can say you have some fruits. Say I have some fruits. This is how we define a list, just a bracket like this. And now this is an empty list, there's nothing in it. So we have some fruits. So our fruits basket is empty. So what do we want inside of it? We can have mangoes. You can have mangoes. You can have orange. We have bananas. So now we've just used our list to represent a collection. That's a collection of fruits. So that is just what a list is. I hope we understand. So if, for example, we want to access any item within this list, currently, how many items does our list contain?
3.
3.
3, okay. So let's assume we don't know now. We want to say, we have this basket of fruits. How many kinds of fruit do we have in it? So there's a function for that. You can simply say len, which is length, then put our fruits in it. So if we run this, it tells us how many we have, which is 3 items. So if, for example, we want to access any of this item within our list, so say we want to know what the first item is in our list. I can say, okay. Let me say the first one. Who can help me out here? It's DevOps. He's not a DevOps person. We want to get the first item on the list. How do we get it?
We say list all. Wait,
Up?
so I try to say list mangoes, or we don't need to use the word mangoes.
No, I say we want to know, what is, so assume we do not know it is mangoes, or maybe we don't know, but we want to get this item, and what is the value of this first item? What I'm simply saying is this. If you recall, we say each of the items in our list is
In strings.
yeah, they are strings. They are strings. But then they also have a place, an order after them. For example, they have an index to them. So this is the first, the second, and the third. So in Python, or usually most programming languages also, they are numbered from 0 in increasing order. So this would be, I have an index of 0, 1, and 2. So if you want to get any of these values from here, so we simply put a bracket in front of our variable name here, of our variable, which is fruits, and then the index. What will be the index of the first one?
0.
Okay, 0. And that should give us what I was asking, mangoes. So say we want to print out banana.
The fruits 2.
So yes.
So this is happening because we know how they're arranged, or we know the chronology of how they come. So if we don't
Yes.
know, we need to find out. Is there where we can just say list all, let's present all the string.
No, I don't understand your question.
Like list everything in the boxes, like mangoes, oranges, bananas. If we don't know how they're arranged, we just want to see all of them.
You want to get their index. You want to get their index, or what?
Yeah, more like that.
Okay, you want to know the position of all of them, or
Yeah.
you just want to print it out?
Yes. Yeah. So we want to know the position of all of them.
Okay.
Because I'm just saying, so if we already know mango is 0, oranges is 1, banana is 2. If we didn't know that information, and we need to say we need to get just mangoes. So is there a way for us to get all, everything, to see all of them? Because I assume this data is not going to be presented the way it is, especially if it's a large database that stores so much.
Yeah, usually, usually you might want to do a loop. and we haven't gotten to that yet. You might want to do like a loop through it. And while looping through it, you get the index of each of them. For example, well, I may not understand it yet, but let me
No,
just show.
if we've not gotten to that yet, you might just take your time and get to it and
Yeah.
just move slowly.
Yeah.
Yes, please.
You just something like so yeah,
Okay.
something like this loop. But
Yeah.
we are
Yeah.
still getting to the looping aspect. For let me just say, well, a loop is just like repeating a task for a certain amount of time.
Okay.
So this is not too complex, but when we get there to make sense to you. But for now, all we need to know is we know the index, but it's a small list, so we can just say, okay, this is the first one. Position is 0
Mhm.
or 2 or 1. So, for example, also, there are other things we can do with a list. Basic things like, yeah, like we said earlier, each of these items now are strings. So we can also work with them individually as what we did with variables up here. For example, we want to get, now we know that this fruit 2 here will give us banana, and we know that banana is a string. We can also perform from the operations we did and say, oh, let's get it as an uppercase. What do you think is going to happen here? Yeah, just like that. Or you can say 0. Can tell us what will happen, Vivian. What will be the result of this?
Can you please ask your question again?
Huh?
You
I
said
said,
what?
what will be the result of this?
It's going to be giving us something about the first item in
Yeah.
the list, which is the mango, but I don't know what title now.
We had an example earlier. So if this will give me this, so what would this Give me.
Mangoes.
Give mangoes.
Yeah, what will happen to the mangoes? That's the actual question.
It to be in string.
Yes. That's not all.
But I don't think that it's just going to be mangoes.
Yeah, then what would it be?
It will be showing the only mango. It will show fruits. It will show us the fruits, and that there will be, I don't know, there will be a mango showing.
You're saying we'll have uppercase, it'll start with uppercase.
Yes, yes, yes. Thank you very much. That is the what I was looking for. So simply saying, so if we have a collection of numbers, like when I say, oh, what would be the result of this?
I think it is going to be a calculation there. Maybe that would be 9 or something.
Yeah, that would be 5 plus 4.
Yeah. Now we what?
That's correct. That would be the third 5 plus 4, I think. Yeah, 5 plus 4.
Okay. So we have here an index of 3. This will be 0, 1, 2, 3. So this will be 5. And this would be an index of 2. So this is 0, 1, 2. So 5 plus 4, 9. As simple as that. That's how we work with lists. Any question?
No.
No question.
So we have our basket of our fruits, a list of fruits. Say we want to add to it. So we want to add more fruits to it. What we can do is there is a method called append. So who knows what happens when we do this?
Error. Sorry, no error. The grape is going to be added to the list that we already have.
Yeah, this we added to the end of the list. So what we now have right now would be yeah. So our grapes is a non-part, is not part of our in our baskets of fruits. So we decide to remove, we can also decide to remove an item from it. Now to remove, we need to know the index of what we want to remove. So we don't need to know the index, I think. We can decide to remove our oranges. So we no longer have oranges in our fruits collection. All right. So any questions on the list? So let me show one more thing before I leave this. I'm going to now. If, for example, if we try to access an index that is not, say, 5, we get an index error. We can see why we have this index error. The table tells us, yes, Vivian, can you tell us why you're getting this index, this error? Hello?
Hi.
Yeah.
Sorry, I didn't get the question.
I mean, what I did here now, this, I wrote
Oh, okay.
8 and 5 here. Trying to get the the fifth or fourth item in our list.
Yeah, because we don't have up to 5
Okay. Thank
item.
you. That's what I wanted to hear. Okay. So let's start. Let's see how to do this. So if you want to okay. So we have items in our list, and say we want to slice or remove some certain amounts of item from the list. So this is an example representation. So we start with, we put the start of the index and then the end. Index. So if you want to get the first three items here, you say, okay, this one starts from 0, 1, 2, 3. So we can say, okay, now let me say the first two. So this will be the start index, that's 0. So we want to get up to banana here. And we can say then the end index. And we have the last index here is 3. So we use 3 here. So we always put the index after the one we are looking for. Okay. Right. If we have put, we know that the index of banana is 2. But we want banana. If you have put 2 here, it wouldn't give us what we want. That is just how it works. So we see that it removes banana from it. So we wanted banana, so we put the index of 3 in it. That's just one of the rules or the syntax of slicing a list. It's not there's no magic to it. It's just the rule of how it works. So if you wanted everything, we will have said 4. Or we remove here. We leave it blank. So it gives us everything. Or if you wanted from the second one, which is index of 2. So it removes the first one, which is sorry, 1. So if you remove the first one, remove this one, and gives us everything that is here from here. Okay, I hope you understand.
Yeah.
So let's move on to dictionaries. So dictionaries is another data type, which is represented with a brackets or curly brace. like some people call it. So when we have something like this, so when we have a bracket like this, it's a dictionary. It's another data type, a way of representing data too. So more like when we have a key value pair, it's called. What we mean by key value is, like now we have a key, we want to represent, say, a collection of data about somebody. You can say, hey, let's say Mike. Or what do we know about Mike? You can say, oh, we know his name. So this is the key name. Or let's say his first name. His first name is Mike. So this is the key, and this is a value. You can say, it can be as many key values in there. And also say his last name. And then I also have this, oh, how old is this person? $50. So the height of so we'll simply use a dictionary to just hold a set of information about something. And say, unlike a list where we have a collection of values. We have this number, this number, this number. We can't really describe what it means. What does this 6,000 mean? What does it mean? It's just in this collection. What is it trying to tell us? But in a dictionary, we can, yeah, this is the key. It tells us, oh, first name. Wow. You know that the first name is Michael, so it has a meaning. So this is called the key, and it is called a value. So if you want to access them, for example, so you can print this out.
Like 4:30, 4:10 for wow. Even about $64 gan.
You can print this out. Okay. Say, what type is this? Dictionary type. You can say the data type also. So if, for example, okay, option. So we have our mic here. We want to know the first name of this dictionary. So we want to access that key. We can simply do what to be the outcome of this. Install. What will be the output of this? Someone else.
He's gonna print his Michael Jackson. I mean, sorry, Michael. He's gonna print his first name in full.
Yeah. Okay. So you can also say the same for the age. So that's how dictionary works. Let's say, oh, we already created our dictionary, and we decided, oh, I forgot to add a certain information like the weight of this person. So we can see height is equals to, sorry, so it added our weight for us. So that's a dictionary. We also have tuple. It's also another data type for dealing with collections too, which is very similar to a list. But the difference is a tuple is immutable. It means once it is defined, you cannot change its value, unlike a list where we can remove, we can add, and you can change whatever is inside the list. But a tuple, once we define it like this with two brackets like this brackets. Parentheses like this, we cannot change its value. For example, we have defined this on it. So we say C equals to this. So we now want to, here we want to change the value of as index 3. It will raise an error. It does not support that. Means we cannot add, even if you try to append. Do it. Most of the functions we can do on a list, we can do in it too. No, not most. Some of the functions we can do on a list, we can also do on a tuple, except the ones that changes its value of any item. That will not work. The only difference between a list and a tuple in times of assignment is the type of brackets that we use. But they still the same, perform almost the same function, except we cannot change its value. I hope you understand what I said. So all the things that we've done so far, except the things that changes the value, not work. All right. Any questions so far? Any question? No. So okay, let's move on. Okay. So let's say conditional statements. So we have a variable a equals to 33 and b equals to 200. We have this symbol familiar with a greater than symbol, less than symbol, and then equals to, and this is not equals to. So these are conditional operators. So let's look at some Boolean operations or conditional operations. For example, if we say 12, tells us that it's true. So this is 12 is greater than 6. That returns a true value. If we say less than 6, tells us that it is false also. If we say, we know that 12 is not equals to 6, so that will tell us false. And if we say, what will be the value answer to this? Hello? Mr. Derek?
Yes, sir.
Yeah. What will be the answer to this?
Can you give the question again?
I said we have 12
Yeah.
and we have 6. And we have these operators. This is the greater than, the less than, equals, not equals. So I'm trying to show some Boolean operations, or for example, like I showed earlier, we knew that 12 greater than 6 will tell us that, yeah, this is true because 12 is greater than 6. And then we show that 12 less than 6, no, it is false, and it told us that it is false because 12 is not less than 6. Now I'm asking, this 12 not equals to 6, what would be the value of that?
True.
True, yeah, thank you. It's true that 12 is not equals to 6. So these are Boolean operations. I mean, Boolean meaning that it's going to give us either a yes or a no. That it's going to the value can either be true or false. Yeah, there's no in between. Two possible outcomes. It's a Boolean operation. So you cannot tell us that, cannot give us any other value besides true or false. And these are the operators that helps us with such kind of things. So this is the basic concept when we want to do conditional checking. For example, like this program we have up here, we said A equals to 33. And we say B equals to 200. So now we're asking the program if B is greater than A. We put our colon here. Enter. Now these are editor here. It gave me this indentation automatically. There are some that may not give us, so we can just use our tab key and indent it. It has to always be indented if we are writing an if statement. We always have to indent. So if you don't indent it, there will be an error. I'll show the error later, but whenever we write an if statement, and usually we use an if statement to make some conditional statements like what we are trying to do here. So we said if B is greater than A, we put this as colon, colon here, indent, then write the state what we want it to do if B is greater than 0. So we want to print B is greater than A. So what happens here? First of all, our computer will check if B is greater than A. Then if B is greater than A, it will then print this. If it is not, it will not do anything. It will just stops the running the process entirely. So from our observation, we know that yes, B is greater than A. So let's run this. Yeah, B is greater than A. So what actually happens here is it does this Boolean operation. Then let me print it out here. You can see it. So yeah, you see that it's true. That's why it gives us it's true and it does this. But if we now say or if B is less than A. Let's run this and see what happens. Nothing. It didn't print it out. So it did not print it out because it is false. B is not less than A, so it doesn't print this out. So then we know that there is only two possible outcomes to this. There's another statement that we use alongside if. It's called the else statement. Else. Print. So initially, when we run this, so we know that B is greater than A. So we run this. Yeah, so it told us yes, B is greater than A, because it is true. So let's try and change the value of A. Let's make it 1000. So who can tell me what happened? Is it Vivian?
So you mean what will happen if we run the,
Yes. Remember, we've changed the value of A to 1000 now.
yes, so if we run the same syntax, is gonna give us no output because B is not greater than A.
No, it's give us an output.
Okay. B is not, yeah, it's gonna be B is not greater than A.
Yes.
Yeah.
Thank you. Yeah. B is not greater than A. So let's now show this. So there might be other conditions that we want to add to this code. For example, we know that there are some other possible states of A and B. It also could be possible if we now say A is equal to 200 and we run our code. What will happen? First of all, when we print this B greater than A, but we know that A is 200 and B is 200. What is going to be the output of this, Mr. Omi? We know that A is 200 and B is 200. What will be the output of when we try to find out if B is greater than A? Will it be true or false?
False.
False. Okay. So then, if it is false, what will be the output of this? We'll still have that B is not greater than
It's
A.
not greater than A. Yeah.
Yes. But then we know that A and B are equal. So we could add another condition to this statement here and say, oh, I also want to capture that possibility of A and BE being equal. So we can say A, there's this statement, else if we can now say B equal A. We also put our column, enter, then we also indent, then put parentheses. B equal A. Yeah, B is equal to A. So we capture this possibility. So what happens now? It checks if, oh, is B greater than A? No. And it comes to the next one. Checks for this condition. Is B equals to A? Yes. It always does this in this particular order. It will first check for this, then it will check for this. Then if none of these conditions are met, then we now say, oh, then print the else. So what will be the output of this program?
B equals to A.
False A. Yeah, thank you. But then we can also decide, oh, let's make B less than A. Call it 10. And let's write another condition that captures this possibility too. Let me say L if B is less than A, then print B is less A. Then what will now? So we just use this else to now capture if all else has everything, none of the conditions are met. So our program will check, oh, is B greater than A? It checks it, then it runs this one. Oh, is B equals to A? It checks it, then it runs this one if that is true. If B is B less than A, if that is true, it runs this one. And if none of these conditions are met, then the else statements, it now captures it. Or if we remove this else, nothing will happen if none of our conditions are met. But since it is there, Then, if none of these conditions are met, it will now do print our else statement. Yes. Okay. Any question?
No.
Okay. Okay, so before finally, there's also we also have the greater than or equals to, and we also have the less than or equals to. We also have or and these are also Boolean operators. Okay, so we'll consider these ones tomorrow. Thank you.
Yes, thank you so much, Mr. DOZ. So guys, can we quickly circle back to the lab real quick? So basically, for you to connect to the lab, I'm going to do it real quick. For you to connect to the lab, you can either refresh if your connection is of recent, or if not, you can just probably just delete the connection, then reconnect again. Okay, to reconnect, click on this plus sign, enter the host. The connection details are right here. Okay, host is local host. Host is local host. You click enter. The user is Data Labs. You click enter. The password is labs at 123. You click enter. Then the port is 3306. Then the certificate part, enter. Then you want to check if you have connection. Yes, you have all the tables, you have labs and all that. But this is just for the database part of it. So now, let's say you have one of those scripts, okay? Like one of these scripts you have it here. This is just for your practice when you're taking time. So let's say I copy all this, do Control C, and I go to the lab. I probably want to create a new file, new text file. I can select a language. I can go on here, select Python. On here, Python. Then I paste. Then I have to save the file, right? Save as. Save as.
No, fine.
So make sure that the file you want to save is selected, is highlighted on here. So do save as. Okay, I want to have it as test pi 3. Okay, I do okay. Once I have it saved, I can click on play. Okay. You can see what this does. It declared A as 200, B as 10. It says print B greater than A. Okay, that's just the first test. Then if B is greater than A, print B is greater than A. Okay. So else if B equal to A, it will print if print B is equal to A. That's if that happens. Then if B is less than A, it will print B is less than A. You know, through here. So for you to run this part, you just click on play. Okay, and you see the output. Here, false, B is less than A, and all that terminates to the other one. So this is for the lab. Have you been able to connect to the lab? Guys, we need to round up real quick. Yeah, because we're just doing this revision so that you guys get the fundamentals strongly. So any questions? Ms. Vivian, Mr. Olu, Mr. Derek, any questions?
No.
No question.
No questions. Are you able, do you understand the basics?
Yes.
Mr. Derek, Mr. Olu, the basics, is it clear? Do you still have questions on the basics? These are the basics, you know, the basics will by putting all the basics together, we'll get the whole, we'll get a clear picture. Okay. So you guys, you're gonna get the recording. Okay, so you guys can still go through it and pick out all those instances, then do your practice. Okay.
Okay.
So we'll catch up tomorrow. Okay.
Okay.
So any questions, please?